Page 15 of the North Carolina packet. If triangle SLM is rotated 180 degrees about the origin, what will be the coordinates of the image M? And they give you a couple choices here. So they're asking for the coordinates of this point if I rotated 180 degrees about the origin. So when I was working with you in September, we established a couple of rules for rotation. And how did we get these? Well, one of the things we did, I kind of wrote the rules here, and it comes from, if you were to take and do the graph, and I had some graph paper for some of my classes, and you rotate it, you could see how sometimes X and Y switch. So for 90-degree rotations, X and Y switched. For a 270-degree rotation, X and Y switched. For 180 and 360, X is still X and Y is still Y. Now you also see some sign changes. If you do 90 degrees, then what happens is it's like the X is positive, and then the Y becomes the X coordinate, but it's going to be kind of flipped because the positive Y is on the negative. So I guess the easiest way to do it is you could take, somehow try to rotate the point 180 degrees about, or if you happen to remember your rules, 180-degree rotation is just changing the signs of X and Y. So let's take a look and see what happens. So that would be X is -5, Y is 5, -5, 1, 2, 3, 4, 5. So if I had rotated at 90, that means I would go like this. So that would make it 5, 5 right here. Then I go another 90 and it shows up here. So my coordinates are -5, 5. I think the easiest way to do these problems, honestly, is with patty paper or tracing paper where you can actually rotate it and see where the point moves. But on the other hand, you can always memorize the transformations for the reflections.